Hello everyone, my name is Harnit Saini. I am Assistant Professor in Ajay Kumar Garg Engineering College. Today the topic of my discussion is graphs. First we will study about the definition of a graph. A graph is determined as a mathematical structure that represents a particular function by connecting a set of points. It is used to create a pairwise relation between the objects. See, these are the objects, means vertices, right? We are making a relationship between these where we are using a straight line to join them, that is called an edge, and the representation of such a relationship is called a graph. The objects are represented by the vertices and the edges represent the relationship. The graph is made up of vertices, that are nodes, and they are connected by edges, that are these lines, right? Undirected graphs and directed graphs. Undirected graphs have edges that do not have a direction, like we are making this a straight line. This doesn't mean that we are not able to understand in this the line is going from here to here or here to here. So we consider it as a bidirectional, right? That the first object is connected to the second object and second object is also related to the first object, right? The edges indicate two-way relationships in that edge can be traversed in both the directions, right? But in directed graphs, the edges have direction. Now we can say that this edge, this vertex is connected to this vertex, means this first, this is the second one, right? This first vertex is related to the second vertex. The edges indicate the one-way relationship in that each edge can only be traversed in a single direction. Like if we are counting the edge like this, we have to go in that direction only where the arrow indicates. Now what is a null graph? A null graph is a graph in which there are no edges between its vertices. A null graph is also called a empty graph. Means a null graph is a no graph, because graph says it should have vertices and edges also, but when we are having only vertices, we are having no edges, then it is an empty graph or null graph. This is a trivial graph, a graph in which there is only one vertex, right? It is also type of a null graph in which we have only one vertex. Now what is a simple graph? A simple graph is a graph that does not have more than one edge between any two vertices and no edge starts and ends at the same vertex. Means if these are two vertices, see there are two edges that are joining these two vertices. So this is not a simple graph. Now you can see this vertex. This edge is a loop which is starting and ending at the same vertex. So these type of edges are not permitted in a simple graph, right? In the other words, a simple graph is a graph without loops and multiple edges, right? This is a loop and these are the multiple edges. Multiple edges are the edges that are having the same endpoints, right? Now we take this graph. Now we take the vertices 1, 2, 3 and 4. There is only one edge between any pair of vertex you have to see. See, if we consider these two vertices, there is only one edge connecting. If the edge was present here, this was also present, then it would not be a simple graph. Now these edges are not there, only one edge is there, so this is a simple graph. This should be true for all the pair of vertices in the graph, right? Any two vertices, any two pairs, you can pick and check. Now multigraph. A graph in which there are multiple edges between any pair of vertices is called a multigraph. If in a graph, if in any one pair we find that there are multiple edges present, so that is a multiple graph. You can see B and C, we are having 1 and 2 edges. From E and F we are having 3 edges, right? So this is a multiple graph. It is not compulsory that every two vertices have the more number of edges. if any two vertices, are having multiple edges, then it is a multiple graph. Pseudograph is a non-simple graph in which both graph loops and multiple edges are permitted. Now, in the multiple graph, they were only permitting the multiple edges. Multiple edges were permitted in that. But if multiple edges along with loop is there, then it is a pseudograph where both multiple edges and this loop is present. Now, what is the degree of the vertex? Degree of the vertex is, the degree means the edges that are incident on that particular vertex is the degree. Now see, the degree of a vertex in an undirected graph is the number of edges incident with it, right? A loop at a vertex contributes twice, this has to be noted, okay? A loop at a vertex contributes twice to the degree of that vertex. The degree of the vertex V in a graph G may be denoted by degree G and V. Now let's consider this graph. First vertex is A. Now we can see we have to find out the degree of A, right? How many edges are connected to it? 1, 1, 2 and 3. The degree of A is 3, right? Now we come to B. B is also having 1, 2 and 3 edges connected to it, then degree of B is also 3. Now come to C. C 1, 2 and this is a loop, so we will count it 2 times, right? 1, 2, 3, 4. This is 4 degree for C because loop we have to count twice. Now we go to the D. D is also having 1, 2, 3 and 4 edges connected to it, so the degree of D is 4, right? Now we come to E. E is having 1, 2, 3, 4, 5 and 6, right? 6 edges connected to it, then the degree of E is 6. Now F. F is an isolated vertex, right? No edges connected to it, so it is, the degree of F is 0 here. Now that was the case which was undirected graph. Now there is a directed graph. Now we have to see which are edges which are incident on it and which are going away from that vertex. So we have to count the degree in 2 ways in case of directed graphs. Like first we will consider the in degree. In degree means the edges that are coming on that vertex. The in degree of the vertex can be described as a number of edges with V, where V is used to indicate the terminal vertex. Means if this is the vertex and edge is coming like this in on it, and that means for this edge, this vertex is the terminal vertex. Means this edge is terminating here on this vertex, right? In other words, we can describe its number of edges coming to that vertex. So all the in edges will be the in degree for that particular vertex. If we want to determine with the help of the syntax degree minus V, okay, see this, the symbol degree minus V, we can write that in degree of the vertex. If we want to determine the in degree of a vertex, for this we have to count the number of edges that ends at that vertex. Now let's consider this graph. First we will see here 0 vertex. We can see there is only one edge which is coming towards 0. So the degree in degree of 0 is 1, right? And for 1 there are 2 edges that are coming. See, this edge has both the directions, right? So for in degree it will be counted once, and for out degree also it will be counted once. The out degree we will discuss after this, okay? So now the 2 edges are coming towards 1. The in degree of 1 is 2 now. Now let's consider the vertex 2. Vertex 2 is having 4 edges connected to it, but the ins are, see, here 1 and 2, right? And 2 in degree is 2. Now you can note that this edge is counted for 0 also and 2 also, because they are having arrows like this. Direction is this. This is originating on 0 also and 2, terminating on 0 also and 2 also. So it will be counted in both cases, right? Now let's discuss 3, vertex 3. See this vertex, this edge is incident on it and this edge is incident on it, right? Both these edges are having the termination at 3. The in degree of 3 is 2, right? Now come to 4, right? 4, 1, 2, right? 2 edges are coming towards 4. Degree of 4 in degree is 2 for 4. Then for 5, 1, 2, right? The degree of 5 is 2. For 6, 1 and this 2, right? The degree of 6 is 2. Here also we can see that we are counting the edges in various, same edges counted in various in degrees of the vertex. Now let's discuss about the out degree. The out degree of a vertex can be described as a number of edges with V, where V is used to indicate the initial vertex. Now the edge has to move outside, means the edge is starting from the vertex and it is moving outward. So this is the initial vertex for that edge, right? In other words, we can describe it as a number of edges coming out from a vertex. Now these edges are coming out from that particular vertex. With the help of the syntax, now see the syntax, degree plus V means they are going outwards, and we can write the out degree of a vertex. If we want to determine the out degree of the vertex, for this we have to count the number of edges that begins from that particular vertex, right? Now let's take that the same diagram again, same graph again. Okay, now we will be calculating the out degree. Now for 0, let's come to 0. Now if we consider this edge, right, this is in also, this is out also, so this will be counted in that also, here also we will count this, right? So we are counting the out degrees, this will be counted here 1 and this is 2. They are moving out from 0. The out degree is 2 now. Now 1, what are the edges that are moving out? See, check this edge, this is coming in also and out also, right? So that means this will also be counted in case of 1 also. So degree of 1 is 1, right? Out degree means out degree. Then about 2, see 2, these are in, this is in. How, which are going out? This one and this one, right? These are going out. And let's check, there is no bidirectional, this is the bidirectional now. This is going in also and this is going out also. So that means this is the degree of 2 is 3. 1, 2 and 3, right? Now let's consider the vertex 3 here. 3, from 3 which are moving out? This edge, check this edge, this is moving out, right? This edge, this is moving out. Degree of 3 is 2. Now come to 4. 4 again, this edge will be counted in case of 4 also because it is bidirectional. Then this edge, this is moving out from 4. We will not count this edge because this is coming towards 4 and it is not bidirectional, right? This will be counted and this will be counted. That means degree of 4 is 2, right? Now come to 5. 5, this will be counted because this is going out also and this will be counted for 5, right? The degree of 5 will be 2 here, right? Now come to 6. 6, only this one will be considered because this is the unidirectional, which has only one direction, it is not going out, it is coming in. So this will not be counted for 6, only this will be counted, this one. Okay, the degree of 6 is 1 then, right? Now what is a complete graph? A graph in which every pair of vertices is joined exactly one edge is called complete graph, right? A graph in which every pair of vertices is joined by exactly one edge means there is one and definitely one edge between any two vertices of a graph, then it is a complete graph, right? Now you see here the first case, a complete graph with n vertices contains n C2 edges and is represented by Kn. Now see K2. K2 means two vertices, this one and this one, there is one edge, this is a complete graph. Here K3, three vertices, and in every pair this is connected to this is connected to this, and this is connected to this. This is also a complete graph, right? Now let's K4 also. Every vertex is connected to, see, every vertex is connected to every other vertex. See, this is connected to this is connected to this, and this is connected to this, right? No other vertex is left. Similar is the case for the second vertex, third vertex, and the fourth vertex, right? So this is a complete graph. Similar is the case for K5 now. See, 5 vertices we are having, right? Now we will check for one vertex, 1, 2, 3 and 4, right? Means the one vertex is connected to all other left out vertices. If there are n vertices, then the degree should be n minus 1 for all other vertices, all the vertices, right? Now similarly, there are 5 vertices and we have the degree 4 for that particular vertex. So this is the case for all the vertices in the K5 graph. K6 also same and K7 also same. Now connected graph. Now there is a difference between connected graph and a complete graph. Complete graph says there should be an edge between any two pair of vertices, but the connected graph says there should be a path or an edge. Means we can reach from one vertex to every other vertex directly or indirectly. Then it is a connected graph. Now see here, a connected graph is a graph in which we visit from any one vertex to any other vertex. In a connected graph, at least one edge or path exists between every pair of vertices. Now see, we consider the first vertex A in this graph. Now let's see H is connected to A or not. If it was a complete graph, then there should be a direct edge between A and H. But it is a connected graph, we can go here, then here, here and here. Then we can reach H. That means their path exists between the A and H vertices. Now you randomly pick any two vertices and we can see that from that particular vertex we can reach to the other vertex. See, from C we can reach G. See, from here we can go, there is a path. That means this is a connected graph. Disconnected graph. Disconnected graph is a graph in which any path does not exist between every pair of vertices. Now we have to find out that if any pair of vertices is not having a path in between them, then it is a disconnected graph, right? That is the case from A to H now, A to E, A to F, A to D, because these are isolated graphs. These are one graph, but they are isolated. Vertices are not connected to each other. So it is no way to reach F now, right? So we have to we can't reach A to E, A to F, A to G, A to H by any means. So that means this is a disconnected graph. Regular graph. A regular graph is a graph in which the degree of all the vertices is same. If the degree of all the vertices is k, then it is a k-regular graph, right? So now let's see this graph in which the degree of this vertex is 3, this vertex is also 3, this vertex is also 3, this vertex is also 3. So that means this is a regular graph and it is called 3 regular graph, means 3 is the degree of every vertex here, right? Cyclic graph. Cyclic graph means there should be a cycle in that graph. It's not compulsory all the vertices are participating in the cycle, but if we are able to find one cycle in the graph, then it is a cyclic graph, right? Cycle means when we start traversing from one vertex to the other vertex, from one path or any other path we reach to the same vertex again, right? That is a cycle. A graph with n vertices where n is greater than or equal to 3 and n edges forming a cycle of n with its edges is known as cycle graph. Graph containing at least one cycle is known as a cyclic graph. The cycle graph which has n vertices is denoted by Cn, right? Means how many vertices are taking part in that particular cycle. Now see in the first graph how there we can make a cycle. Suppose we start from B, right? From B we can go to A this way, we start traversing these and we finally reach B. So this is a cycle here, right? Similarly here, take the second graph. From B we start here, here, we reach here. Now A and F are not participating in the cycle, but it is a cyclic graph because we are able to find out one cycle in this. Acyclic graph, there is no path which is a cycle here, means no way to make a cycle in that particular graph. That is called a acyclic graph. A graph which does not contain any cycle in it is called a acyclic graph here, right? See, you pick any pair. Suppose we are starting from B. From wherever we go, we are not able to come back to B. From wherever we go, we are not able to come back to G, right? Any vertex. D, no way to come back to D. D, no way to come back to D, this side also. That means there is no cycle in this, that is a acyclic graph. Weighted graph. Weighted graph is a graph whose edges have been labeled with some weights or numbers. The length of the path in a weighted graph is the sum of weights of the edges in the paths. Now there are certain graphs in which the edges have some weights, which tells the amount of the cost it has to be paid to traverse that particular edge, right? So these type of graphs are used in calculating the shortest path type algorithms, right? So this, consider this graph now. Now suppose we have to traverse from 0 to 1. The cost we have to pay from 0 to 1 is 3. 3 may be the weight, 3 may be the distance between 0 and 1, right? So this way. And from 1 to 2 there is 1, 2 to 3 we have to pay the 2 cost here, right? So this way this can be used in different algorithms, and the meaning of the weight also varies according to the algorithm. Now the planar graph. A planar graph is a graph that we can draw in a plane in such a way that no two edges of it cross each other, right? There should not be like this in the graph, right? This way, right? This thing should not happen in a graph. They should be not crossing in the graph, except at a vertex to which they are incident. If it is a vertex, this is a vertex, then it is okay. This is a vertex, then it is okay. But if it is not a vertex, then this type of crossing should not happen in the graph. That type of graphs are called the planar graphs. Now let's consider this graph. See, we can see here it is having 4 vertices, 1, 2, 3 and 4. The edges this and this are crossing to each other, right? So this is not a planar graph. If it is a vertex here, then it is a planar graph. Otherwise it is not a planar graph because there is no vertex and edges are crossing each other. So this graph can be converted to this graph. This edge is drawn like this here only, and this edge is converted like this, right? So this graph is converted to planar graph like this, right? Now this graph, we can see there is a cut here, but we can see the cut here, but there is a vertex here. So this can be considered as a planar graph. The edge is not crossing each other, but they are touching the vertex here, right? Now bipartite graph. Now this is an important topic here. A bipartite graph is a graph in which the vertex set can be partitioned into two sets such that edges only go between sets, not within them, right? Now here we will make two sets, right? Suppose a vertex A, B, C, D is there in one set and X, Y, Z is there in the other set, right? So the edges of that graph should be between A or X, A to Y, A to Z, like this. One vertex should be from this set and one vertex should be from this set, right? They should not be edge between A to B, A to C or A to D, right? The same endpoints of one particular edge, the endpoints of one edge should not be in one set. That is a bipartite graph. A graph G is called a bipartite graph. Its vertex set VG can be decomposed into two non-empty disjoint subsets V1 and V2 in such a way that each edge E belongs to E has one last joint in V1 and the other last point in V2, right? If this is V1 and this is V2. One edges have one endpoint here and other endpoint here. All the edges has to be traversed like this only. All one vertex should be included in first one and second vertex should be included into the second set. The partition V is equal to V1 union V2 is known as the bipartition of G, and we should not leave any vertex. Now let's consider this graph. See here, this is x1, y2, x3, y1, x2, y3 and x4. Now let's see whether it is a bipartite graph or not. So we have to make two subsets of vertices, right? So let's consider this edge, right? It is having the vertex x1 and y2. So we will include x1 here and y2 here, right? Because one endpoint should be in one set and other endpoint should be in the other set, right? Now this is over. Now let's consider this edge. X1 is this. If x1 is here, then y1 has to be here, right? Let's consider this edge. If y1 is here, see this is the edge point is y1 and x2. y1 is in v2, then x2 has to be in v1, right? Let's consider this edge y2 and x2. y2 should be in one v2, and then x2 should be in v1. Yes, this is true for this edge, right? Now let's see for this edge y2 and x3. y2 should be in one, the x3 should be in other set now, right? Now let's consider this edge, right? x3 and y3. x3 is one set here, x3 is here, now y3 should be here, right? This edge x2 and y3, x2 is here in v1 and y3 is here in v2. This is true for this, so we can see that this is okay. This edge is left, y3 and x4. y3 is in v2, then x4 should be in v1. So we are able to partition the set of vertices here. So this is a bipartite graph. So this graph can be drawn in this way also. See, in this way also it can be drawn. We will take set v1 in one direction, x1, x2, x3, x4, right? y1, y2 and y3, right? So if there is an edge between x1 and y2, similarly x1 and y2 we can draw an edge here, right? x1 and y1, x1 and y1, right? x1 and y1, x1 and y1. Similarly we can draw all the edges here. So this graph is converted to this shape also. Similar is the case for this here. We can divide this graph into two partitions, x1, x2, x3, x4 and y1, y2, y3 and y4. So the edges, there is an edge between x1, y1. So x1, y1, here also there is an edge. So this way we can check whether the graph is a bipartite graph or not. Complete bipartite graph means if there are two partitions of the vertices, there should be an edge between all the pairs that are made. See, suppose there is A vertex, so there should be an edge for P, Q and R, right? Similarly, B should be connected to all the three. C should be connected to all the three. D should be connected to all the three. So this type of graph is called a complete bipartite graph. What is a star graph? A star graph is a complete bipartite graph in which n minus 1 vertices have degree 1, right? And the single vertex have degree n minus 1. Now what is happening here? See, this is a vertex, right? And we are having n vertices, means n is equal to 3 in this case, right? One vertex should have degree equal to n minus 1, right? So this is the vertex that is having the degree 2, 1 and 2. Rest all the vertex should have degree 1. So these are the vertex left out, these are having degree 1. So that type of graph is called a star graph. Similar is the case in this and this. Only one will have the degree n minus 1 and all other will have the degree 1. Such type of graph is called a star graph. Thank you very much.